Right, welcome back to Number Sense Academy, and we're gonna take another step. We'll look at another topic in quadratic equations. And today or in this video, we're gonna address quadratic equations in factored form. So we already know that a when you graph a quadratic equation, you end up with a parabola. So in this case, we have a parabola with a vertex at the origin. So it has a minimum. It opens upwards. It's not too tightly squeezed around the y-axis, and it's not too tightly squeezed against the x-axis. So we could make some assumptions about what the value of a is, right, in front of the x squared. Um, what else do we know? We know that it's symmetric along the y-axis. So we know all that. So if I have an equation in y equals ax squared plus bx plus c, depending on what values I have for a, b, and c, I can make some suppositions about what this graph will look like. But if I wanted to graph it and it's in this form, which is standard form, I would either have to use a graphing calculator, some technology, or do the whole thing manually, which could be very tedious. But when I have the equation in factored form, which looks like this, it's y equals a times x minus r and x minus s. So this is called factored form. And in factored form, I still get a lot of useful information. So let's look at what we get. So we have y equals a times x minus r times x minus s. So the first thing that we get is we get an idea about the compression, right? So is it pressed against the y-axis or is it pressed against the x-axis? So we get that information. The other bit of information we get is we have what we call the zeros of the equation. For some reason I was spelling zeros with the E. So no, it's not. So we have the zeros of the equation. And remember, these are x-intercepts. These are given. In some cases, though, you do have to calculate it. And let me just dive into that right now. Because the reason why they're referred to as zeros is because you have a product. So you have x minus r, x minus s. This is a product. So what if I call this u and I call this v? Essentially what I have is u times v. So that's a product. If u equals 0, then uv equals 0. And if v equals 0, then u times v is equal to 0. So the idea here is with these zeros is what value will make this product 0? That's what we're looking at. So, and the way we do that, we're going to take x minus r is equal to 0, and we're going to solve for x, and we're going to take x minus s equals to 0, and we're going to solve for x. So we're going to solve for x in both situations. Okay, so depending on if there's a factor in front of or a constant in front of the x, then it will change how you solve this, because then you have to do a bit of division. But if it's really easy, then sometimes x is just equal to r, and then in this case x will just be equal to s. But it could be that you have, like, say, what can I put in front of? We'll say n times x minus r equals 0. No, not like that. Sorry. You might have it where you have n times x minus r. So if that's the case, we have n times x minus r. So x is going to be r over n, right? And then you might have m times x minus s equals 0. So x is going to be x over m. So you might have to do a bit of calculations to figure out what x and what the values of x are, so that you can get the roots. Okay, so in a typical equation, you'll have a value for s, you'll have a value for r. The x are just constant, so they don't change. Right. So also, the key piece though that we can't forget is that even though we're saying x minus r is equal to 0 and x minus s equals 0, this stems from this very important point that for the x-intercepts, right, y is equal to 0. So I'm basically setting this equation equal to 0, right? I'm letting y equal 0, which means I need one of these values to be equal to 0. One of these needs to be equal to 0 to make this whole thing 0. If one of them is equal to 0, then this whole thing will become 0. And that's why we do all this, to find the zeros. Okay? So when you find the zeros, that helps with graphing as well. Another key piece of information that helps with graphing is we know a is valuable, right? But the sign in front of a is also valuable, because if it's negative, then it's downward sloping, or not downward opening, and if it's positive, it opens upward. Okay, so those are important. Another key piece that I didn't mention yet, but I'll get into and I'll squeeze it in on this paper, is the y-intercept. And the y-intercept happens when x equals 0. So that means we're going to set all of our values where x is, wherever there's an x, we're going to set those equal to 0, and then we're going to solve for what y is, and then we'll get some value for the y-intercept where we have 0 and some value for y, and that's our y-intercept. Okay, I'm going to erase some of this because it's kind of, just for example. Another important factor that we get, I'm going to keep these up here because they help, is it's called the vertex. So the vertex happens at the peak. So it's a coordinate at the peak or at the trough. So the very bottom, it's a coordinate. And the way that we get that, we're going to take, we can find the x value of the vertex. And this is equal to, x is equal to r plus s divided by 2. Okay, so we take the negative of the values that's in the brackets. So we have this, we have a minus r. We're going to take minus, we're going to take r. We have minus s, we're going to take s divided by 2. And we get the x value of the vertex. To find the y value of the vertex, we have to, let me keep that green so we know what we're talking about. So to find the y value of the vertex, we have to sub the x value from the vertex, so x for the vertex, into the main equation. Okay, so we're going to sub into the equation that we got, however way that came in, whether it's in factored form or it's in standard form. We're going to sub, and then we end up with the vertex. Right? These two things make up the vertex. And then the other thing that we also get is what we call the equation of the axis of symmetry. Symmetry. Okay, and it's just x equals the value of x at the vertex. Okay, so it's just this. Whatever this is, that's the equation for the axis of symmetry, but you write it as x equals so that it's an equation. All right. So I'm going to do an example now just to kind of bring this all together. So suppose, and we don't need a whole lot of examples. All you need is one good one. So here's a good one. So we have y equals negative x minus 2 times x plus 3. And essentially we're gonna sketch the graph. Sketch the graph. All right, so what do I need? I know I need the zeros, and I could get those. Within our practice, you'll be able to get these with just by looking at the equation. But let's just do it, mechanically. So the zeros. So I have x minus 2 equals 0, so x is equal to 2. And then I have x plus 3 equals 0, so x is equal to negative 3. Okay, so because the zeros are also x-intercepts, I know that I intuitively let y equals 0. So the coordinate for this is going to be 2, 0. And for this one, it's going to be negative 3, 0. Okay, so I know those coordinates, 2, 0 and negative 3, 0. The other thing I'm going to do, I'm going to find the y-intercept. And we know that happens when x equals 0. So let's plug that in our equation. So I have y equals negative 0 minus 2, and then 0 plus 3. So this doesn't become 0. It becomes negative times negative 2 times 3, which is equal to 6. Right? Negative 2 times 3 is negative 6 times negative is positive 6. So y is equal to 6. I knew I let x equal 0. So the coordinate for the y-intercept is going to be 0 and 6. So we have three very useful things that we can use. Another critical piece that sometimes doesn't show up on the graph from some of the other examples we saw was the vertex. So the vertex, we know we get the x value from taking r plus s and divided by 2. Where's r? This is r, this is s. So x is equal to, so we're going to take, it's going to be 2, right? So remember, we're taking the negatives of these. And then, so this will be negative 3. So it's going to be 2 plus negative 3 divided by 2. X is equal to negative 1 over 2. Okay. So we know where the vertex, the x value of the vertex is. It's at negative 1/2. But I also need to find out what the y value is. So y is going to be negative 1/2 minus 2 times negative 1/2 plus 3. This is where you got to really finesse your mathematics. So this is equal to, so negative 1/2 minus 2 is the same as negative 4 over 2. So I end up with negative 5 over 2. All right. And then 3, if I want 2 in the denominator, I'm going to get a 6. So I get negative 1 plus 6, which is 5 over 2. So I have the negative, so y is equal to negative of negative 5 over 2, which is 5 over 2. So this becomes 25 over 4, which is the same as 6 1/4, which is equal to 6.25. This is going to help me graph it. So this is equal to negative 0.5. So now I can actually put this on a graph because I have y-intercept. I have x-intercept, and I have the coordinate of the vertex. Let me actually write that down. So the vertex is going to be negative 1/2 or negative 0.5 and 6.25. All right. So now let's see what I need. Do I need some big values? Okay, I need a positive 6. Okay, that's the y-intercept. The vertex is at negative 0.5, 6.25. All right. And I know it's downward sloping, right, because of this. And I have my vertex. So all of this stuff, I should have enough to sketch the graph. So let's see what we end up with. So again, I'm going to give more room because of this 6.25. I'm going to give more room to the top. And I'm trying to graph 2, 3, 4, 5, 7, 1, 2, 3, 5, 6. I have y, x. I have 1, 2, 3, 4, 5, 6. Just in case I need it. 1, 2, 3, 4, 5, and 6. So my first point, I need 2 and 0. So let's find those. 2 and 0 is right here. Then I need negative 3 and 0, which is right here. So these are my zeros. Then I need the y-intercept, which happens at 6 and 0. 1, 2, 3, 4, 5, 6. So this is right here. That's my y-intercept. And then the vertex happens at negative 1/2 and 6.25. So let's see how we're going to figure it out. So negative 1/2 is about right here. 6.25 is about there. So we're going to... So that's the vertex. And now I could graph it. So boom, all the way down. And since that's the vertex, I'm going to drop off right away. And that's what it looks like. So a couple of things. I know that it's negative, right? So my graph is facing downwards. I don't expect any massive transformation to the arms because it's just negative 1, so it's standard. But the vertex got shifted over negative 0.5, and the y-intercept is 6.06. So it shifted up. So we flipped it up, brought it all the way up to 6. And I know here I have a max at the vertex. And then the axis of symmetry, just in case I forgot that, is x is equal to negative 0.5. So that's how that works. All right, so the one last thing we're going to do, let's see if we can work our way back when we're given an equation. So suppose we have this graph, and this is very bad. Let me actually try with this. Geez, not even better. Okay, one more try. Let's go. Okay, so I have the graph looks like this. So let me just put some points on this. 1, 2, 3, 4, 5. negative 1, 2, 3, 4, 5. And then I have 1, 2, 3, 4, 5. And 1, 2, 3, 4, and 5. So I have a couple points. I have one at negative 5 and 0. And I have one at negative 1 and 0. Then I have a y-intercept at negative 6. So I got to bring that down a little bit more. So I have a y-intercept here. And then I have a vertex at 3 and 3.5. So where's 3.5? Sorry, negative 3 and 3.5. So 1, 2, 3, and then 3.5 is right here. Okay, so I'm comfortable with how the graph looks. Okay, so let's highlight what we have. I have the zeros, I have the vertex, I have the y-intercept. Okay, so I need to get this equation in at least this form. Once I get it in this form, then I could, if I'm in the mood, I could put it in this form. But let's just get it in this form first. And then we'll see how we feel about changing it into the other form. So what do we need? We know we have the intercepts. So I'm going to write down what I already have. So I have y is equal to a times x. This value is negative 5, 0. So it's going to be x plus 5. Right? We always take the negative. And then this one is negative 1, 0. So it's going to be x plus 1. Now we need to find a. So the other thing that we need to check is to make sure that the vertex is actually what it is. So if I was to check for the vertex, by doing x is equal to r plus s divided by 2, I end up with 5 plus 1 divided by 2. Well, negative 5 plus 1 divided by 2. And I end up with, they're negative. So negative 5 plus negative 1. So negative 6 divided by 2 is negative 3. So it's there, negative 3. Right, so the x value is there. And this also gives me the axis of symmetry. So x is equal to negative 3. So we're good. But I need to find a. How can I find a? The easiest way to find a is to use the y-intercept. So use y-intercept to find a. Okay? Reason is because x is going to be 0. So these two values will be 0. If they're not, you're going to be doing a lot of work. So let's find that. Y is equal to a times x plus 5, x plus 1. So y, if we use from the y-intercept, it's negative 6. So we have negative 6. A, x is 0. X is 0. So I have negative 6 equals a times 5 times 1. So negative 6 is equal to 5a. A is equal to negative 6 divided by 5. Okay, so the one thing I'm satisfied with is that a is negative. This is important because clearly it's opening downwards. So that's important. The other thing that I'm okay with is that negative 6 over 5, if you actually work that out on a calculator, you'll see that it's not that big of a number. It's bigger than 1. It's just 1.2, right? So essentially what you have is 1.2. So something a little bit more compressed than if it was just 1. So I have my equation, my final equation is going to be y is equal to negative 6 over 5 times x plus 5 times x plus 1, or I prefer negative 1.2 times x plus 5 times x plus 1. Okay, so in this question, we were able to work our way backwards from being given a graph or given a sketch of a quadratic equation, and we're able to work our way backward to get to what the equation looks like. All right, thank you.